All right, let's dive right in. Today, we are taking a deep dive into one of the most powerful, complex, and honestly, game-changing technologies out there. Large language models, you probably know them as LLMs.
I mean, think about it. They can write poetry, they can answer your toughest questions, they can even write code. It feels like we're crossing a new frontier, where the line between what a human writes and what a machine generates is getting blurrier every single day. So, how on earth do they do it?
So, to really wrap our heads around LLMs, we've got to start with the most fundamental question of all. What exactly are these things?
I love this quote because it really captures the strangeness of it all. It points to this idea of a mind that's completely alien to us. It's not biological, it doesn't have emotions or awareness. It's a form of intelligence that's built from pure data and math, working at a scale that's just hard to comprehend. Okay, so here's the absolute key. An LLM isn't thinking in the way we do. It's a massively powerful prediction engine. Just imagine you created this gigantic, intricate map of all human language from pretty much every book and website ever made. The LLM doesn't know what a cat is, but it knows with incredible statistical certainty that the word cat is very likely to show up near words like purr, meow, and kitten. It's a master of patterns, not a conscious bee.
All right, so now that we've got a handle on what an LLM is, let's pop the hood. How did we get from those, clunky old computer programs to the fluid, conversational AIs we interact with today?
For a long time, we tried to teach computers language by hand-coding a bunch of rigid grammar rules. And, well, it was incredibly limited. The real change happened when they started letting the machines learn from data themselves. But the absolute earthquake, the real game changer, was the transformer architecture in 2017. Before that, models read a sentence word by word. The transformer could look at the entire sentence at once and understand how every word related to every other word. That ability to see the whole picture is what unlocked real context, and it's the foundation for literally every major LLM we have today.
So building one of these models is kind of like a three-stage rocket launch. Stage 1 is pre-training. You just unleash it on a mind-boggling amount of text, and its only job is to guess the next word over and over and over. That's how it learns grammar and facts. Stage 2 is fine-tuning, where you give it specific examples to get good at certain tasks. And then the final and maybe most important stage is RLHF. This is basically sending the AI to finishing school, where real humans rate its answers to teach it to be helpful and safe.
So after all that complex training, what are these models actually doing out there in the wild? And who are the big names in the game right now? Honestly, LLMs are already woven into the very fabric of our digital world, often in ways you don't even notice. They're helping write the articles you read. They're assisting developers build apps faster. And they're making search engines feel like they can practically read your mind. They're quickly becoming the invisible engine driving a huge part of the internet. It's easy to think of this as a race to build one single best AI. But that's not really what's happening. It's a race for specialized greatness. It's like the Olympics. You have different athletes for different events. If you're a coder, Claude 4 is your champion. Need real-time data and advanced math? Grok 3 is the one to beat. And when it comes to actually understanding video, Gemini is in a league of its own. Each of these titans is carving out its own territory.
And just to give you a taste of the kind of power we are talking about, 93.3%. That was Grok 3's score on a graduate-level mathematics competition. This is not just about remembering facts from the internet. This is a sign of incredibly sophisticated reasoning, the ability to work through complex, multi-step problems at a level that rivals human experts. It's kind of mind-blowing. The speed of this field is just staggering. So let's look ahead. What's just around the corner? What are the big trends that are shaping what comes next? For a little while, the strategy was just bigger is better. Build these enormous, power-hungry models. But that's incredibly expensive and has a huge environmental cost. So now, the trend is shifting toward what people are calling green AI. Smaller, super efficient, specialized models that are cheaper to run and better for the planet. It's about being smarter, not just bigger.
Okay, and this is where it really starts to feel like sci-fi. The next big leaps are incredible. We're moving beyond text to true multimodality, AI that can see, hear, and process the world more like we do. Then there's the reasoning revolution, creating models that don't just spit out an answer, but can actually show their work. And maybe the biggest deal of all, autonomous agents. AI that doesn't just talk to you, but can actually do things for you online.
Now all of this sounds amazing, but this kind of power doesn't come for free. we have to talk about the challenges, the risks, and the so what of it all.
You know the old saying, with great power comes great responsibility? Well, what does that really mean here? As these tools become woven into the fabric of our society, what are the trade-offs we need to be thinking about?
Well, there are some pretty big hurdles. You've got hallucinations, which is when an AI just confidently makes things up. Because they learn from the internet, they can also pick up and even amplify the biases found in that data. And of course, there's the huge challenge of misinformation, the ability to create fake but convincing content on a massive scale. Managing these risks is every bit as important as developing the technology itself.
So, to leave you with one final thought, this quote from OpenAI's CFO really nails it. The next big step is all about agents. We're shifting from AI you talk to AI that acts for you. A future of real human-machine teamwork is coming, and it's probably coming a lot faster than any of us are prepared for. The only question is, what kind of future do we want to build with it?